is the 18th, I think. Okay, so 4.1, Algebra of Functions. When we talk about algebra, we talk about addition, subtraction, multiplication, and division. When we talk about functions, we talk about f of x, g of x, t of p, and so on and so forth. So obviously, we want to add and subtract, multiply and divide functions. So the notation is very self-explanatory. So when we are asked, for example, to find f plus g of x, it really means f of x plus g of x. Of course, I must be given, so we have f of x and g of x. Because if I don't have f and g, I cannot tell you determine f plus g of x. So we have f and g. Now, if I ask you to determine f minus g of x, what will you do with f and g? Obviously, common sense will tell us to
just change the plus and minus there.
Correct, I'm subtracting, of course. There is nothing else. What if I ask you to find, and listen to the name of the function, fg of x? What am I asking you to determine? What do you think? It's the operation that it says f times g. That's what it says. Fg, if there is no operation symbol between f and g, it must be multiplication. Last one, f over g, by definition, is f of x over g of x. Of course, that's what it says. That's the definition. But this time, I have to write if. I didn't write if for the sum, difference, and product, but I have to write if for the ratio. Why am I writing if for the ratio?
I'm guessing you want to avoid a divide by zero situation.
Exactly. The division will not exist for particular values or value if the denominator is 0. It may exist for others, but not for all, right? If g of x can be 0, then I have to make some adjustments. Okay, now before we look at an example of how to create these functions, we have to talk about common domain. Because we will not always be able to create these functions. It depends on the domain, if they have a common domain. So let's look at a graph of two functions. So here is the green function, f of x. And let's say between -4 and 5. And let's say I have a purple function. Let's say between 2 and 15. And let's suppose I would like you to determine fg of 6. You will say, that's easy. It's f of 6 times g of 6. No problem. But there is a problem. What is the problem?
F of x is 6 is out of the domain of x.
Exactly. 6 is here, and this piece is undefined. I cannot multiply a number by an undefined number. So I will have to say the product does not exist at 6. Sorry. So now I'm going to ask you, if I want you to determine the product or the sum or the difference or the ratio, which piece of the real line I have to ask you to evaluate it for? Only between? Only between? Which numbers? 2 and 5. Because between 2 and 5, they both exist. Outside of 5, only one of them To the left of 2, only the other. So that's what we call the common domain. So I cannot ask you to determine the sum, difference, product, and ratio on any other piece, but what is called CD, common domain, 2, 5. If I'm outside of that interval, you will not be able to evaluate or determine sum, difference, product, and ratio. Also, there is a problem with the ratio because f over g, see, g, I didn't write it. That's why it wasn't clear. I'm sorry, this is g of x. So CG is 0 here. Let's say at 3. So I will be able to determine the sum, difference, product on the interval 2, 5, which is the common domain. But I will not be able to determine the ratio at which point? When x equals?
0. That's 3.
When x equals 3, because g of x, which is in the denominator, will be 0. Okay? So we cannot determine these functions before we make sure that there is a common domain. So let's take a look. So for that one, we're going to pick a problem. Or I will pick a problem. I will make one up. Yep. Good. So here it is. Let's say f of x equals 2x squared plus 1. And g of x equals x minus 2. What is the domain of f? What is the domain of g? So what is the domain of f and what is the domain of g? What type of functions are they?
One's a quadratic, and the other linear equation.
Very good. So both functions are called polynomial. And we have to remember moving forward that polynomial functions are always defined on all real numbers. These are the nicest, one of the nicest category, right? Polynomials, one of the nicest category of functions defined everywhere. So negative infinity to infinity, negative infinity to infinity, then what is the common domain? If there is no common domain, I can determine these functions, sum, difference, product, and ratio. So what will you say? What will be the common domain? Anyone? Common domain. Say it again. The domain has to be an interval or a number, but not infinity. Infinity cannot be an interval or domain. So one function is defined on all real numbers, the other function is defined on all real numbers, then the common domain must be? Of course. Of course. They have everything in common. They both exist at the same time. So for any x value, both exist. Excellent. Good. So my next question would be, so after we write the common domain, so always remember the common domain will always be the domain of the function sum, the function difference, and the function product. Always. So we don't have to write it one more time. So the common domain will always be the domain of the sum, difference, and product. What about ratio? I don't know. I don't know about the ratio. We have to determine it and see what it is. So we don't have to write this again. So let's find f plus g. First, we have to write the definition. Please write the definition as f of x plus g of x, because that's what it means. Then replace f of x by 2x squared plus 1 plus replace g of x by x minus 2 and perform the operations, presenting everything in descending order, because the result is also a polynomial. So you will write 2x squared plus x minus 1. This is a new function determined by adding the given functions. Let's determine now the difference. There's a lot of writing in these, but it's really nothing to worry about. Please write the definition as f of x minus g of x as the starting point, so we don't forget what this means. And then replace f of x by 2x squared plus 1. And don't forget to distribute the negative symbol, or the negative sign, or the negative 1 to both terms in x. X has two terms, so negative x plus 2. So then 2x squared minus x and plus 3. If you want to write it, just in case you have any doubts. If you have any doubts, let's write it and put parentheses around it. And you distribute negative 1 to x and negative 1 to negative 2. You understand that the domain of these functions is definitely all real numbers. There is no discussion. This is always the same for any two functions. Now we have to determine the product. Please write the definition. It's f of x times g of x, in parentheses 2x squared plus 1, multiplied in parentheses by x minus 2. Yes, I have to distribute. I have to FOIL. It happens that these are both what type of polynomials? How do we call them? What type of polynomials are we multiplying?
Binomial.
Two binomials, excellent. So we can use FOIL. 2x squared times x, 2x cubed, 2x squared times negative 2, negative 4x squared, 1 times x, and 1 times negative 2. And this is the product of the two given functions, a totally new function determined with the product. Finally, we get to the ratio. So let's take a look. F over g of x. By definition, this is f of x over g of x. I copy 2x squared plus 1 over x minus 2. And I have to have an if. And we discussed that some time ago with rational equations and so many other types of expressions that are rational. If what?
Well, it kind of jumps right out at you that you don't want x to be 2.
Excellent. Great job. So then we know the domain of the first three, but now we have to find the domain of the ratio. What will be the domain of the ratio? From the common domain, I have to remove this value that makes the ratio undefined. So then what is left? In interval notation between negative infinity and 2, union 2 to infinity. As you see, we went back to the common domain, but we had no choice. We had to remove the value that created something over 0. Any questions on this? Any questions? Any questions? Okay. There exists a fourth way of creating new functions. And that is called function composition. Which is not addition, subtraction, multiplication, and division. It's not. It's a totally new way. And no, it does not require common domain. It does not require the functions to have a common domain. A common domain. It has potentially other problems, but not common domain. And here is the notation. Bless you. So here's the notation. F, a circle, G. Or G, a circle, F. Of course, this is not the way we pronounce it. I'm going to write it here. F comp G. Here, G comp F, the composite. So that's in short, abbreviated. So this is F comp G of X is the composite function. Composite function of F and G. The other one is the composite function of G and F. In short, F comp G or G comp F. We can continue indefinitely. I can have any function composition. I can have F with itself. I can have F with G and with F again. And it has no end. We're going to look at the main F comp G and G comp F. And also we're going to look at functions and go backwards and decompose them. Not yet. So first of all, let's understand what this means. The F comp G and the G comp F. So let's create 3 bubbles. We are talking about F comp G. By definition, this is F of G of X. This is what it's called the inner function. It's the first one we apply to G. So if I have X here, the first one we will apply to X, sorry. If this is X, we first apply G to it. What do you think function F will be if G is the inner function? What do you think F will be if G is the inner? Obviously the outer function. So after we finish and we get G of X, I apply G to X and I get G of X. To this number, I apply function F to get F of G of X. So this time we're not adding or subtracting, multiplying or dividing, but we are replacing X in a function by another function. And that's what we call function composition. And you'll see in a minute how it works. I'm not going to test you on finding the domain. This is, in my opinion, beyond the scope of the course. But I just want to say one thing. For function G, what is this set called? What is the name of this set for function G, where we pick X values? How do we call it? It has a name. We have a function G, and this is the set of values of X. What is the name of this set?
Is it the domain
Of
G?
course, of course, of course. Domain of G. Excellent. Now here we get the values for G. Not the values of X, but the values of Y. How do we call this set? The range. Range of G of X. Perfect. Forget about G. What is this set for F? The same set. What does this set represent for F? It's where the x values of f are coming from. So what will this set represent for f? How do we call it? The domain. Very good. Domain of f of x. See what the problem could be? The range the range of G may contain 5, and f is not applicable to 5. F is undefined at 5. So here, the common domain means nothing. They may have a common domain or not. No, we don't care. But the potential problem is that the range of function G and the domain of function f may not work well together. You're not going to be asked in this class to determine the domain of a function composition, however. But I just wanted to point out, this is not a question of common domain. It's a question of whether the range of G works well with the domain of f. These two in here have to work well together. If G brings 5 and f is not applicable, is not defined at 5, then the chain is broken. Done. We cannot determine this function. We have to go back and readjust the domain of G. But that's not part of this course, so don't worry about it. I just wanted to explain what the potential problem could be. I want to go back to our previous functions. We had, again, f of x. I think it was 2x squared plus 1, and g of x equals x minus 2. And we want to determine now f comp g, and later on g comp f. Like before, we have to write a definition. The definition is f of g of x. We have to replace, do not cross it out like that, I'm just making a point. We have to replace g of x by what it equals to, which is x minus 2. So then this is f of x minus 2. Sometime a few weeks ago, we discussed this kind of situation, right? In which, and you had that on the test. That's why, for this. So when I look at f, if I'm asked to evaluate f for 0, I will say 2 times 0 squared plus 1. If you want me to evaluate f for 5, I will say 2 times 5 squared plus 1. But now, I want us to evaluate f not for 1, not for 2, not for 0, not for 5, but for x minus 2. How do I write it? That's why we had this a long time ago, and on the test. So please tell me what to write next. Say it again. So I have to write the next step. What will the next step be? Yes? So one more time. Let's do this again. If, which is not the case here, if I'm asked to find f of 0, I will write 2 times 0 squared plus 1. Agreed? If I'm asked to find f of 5, I will write 2 times 5 squared plus 1. Agreed? This is not what I'm asked. I'm asked to find f of x minus 2. But it's the same thing. So please tell me what to write. This was just a numerical example to refresh your memory on what to see in this function, how to assess the function. So what will I have to write? 2, indeed. Awesome. Then, in parentheses. If you don't say parentheses, then this is wrong. Good. Parentheses. What else? Of course. Of course. That's exactly what I did here. Instead of 0, instead of 5, I have x minus 2. And then? And that's it. However, excellent. So, however, I have to expand and simplify. How many terms we get when we square a binomial?
3.
Excellent. What are they? I'm hoping that you're not going to continue foiling. I'm hoping that we are moving away from that, but I can't force you. It will be more difficult later. But, again, it's up to you. So please tell me how to continue.
Well, the first term is x squared.
Yes, very good.
And then 2 times the sum of the...
Yes, 4x plus 4 plus 1. Excellent. 2 times the first times the second is negative 4x plus the second term squared. Excellent. So this is 2x squared minus 8x plus 8 and plus 1. So 2x squared minus 8x plus 9. This is the function composition of the given functions. Okay, how did we determine that? With G as the inner function and with F as the outer function. Now we want to do the other one. G comp F. G comp F of X. Can anyone give us a definition? G of F of X. Don't cross it out like that. I'm making a point. This is 2x squared plus 1. So now we want this. What does G say? G says blah minus 2. So how do I write this? Excellent. Yes. Plus 1. So G was blah minus 2. Minus 2. Very good. Awesome. So this is 2x squared minus 1, and this is final. And this is the function composition of G and F. Any questions?
Is there a graphical way to understand, or do you have that, what that really means?
It's a new function, and you will understand it in just a moment. Yes, it's a very good question. I was going to do this anyway. Function. This is with polynomials is a little bit more difficult to see. Decomposition. We composed function. Now we want to go backwards. So here are examples that are much easier to see. So let's say f of x equals 1 over x squared minus 4. I would like us to identify an inner function and an outer function that I use to create this function. And again, it always goes back to how do I evaluate it. So if you ask me to evaluate this function for 10, which operation will I perform first? Say it again. Any number. 15. 2. I can't for 2 because it will be 0. Let's say 1. What should I do? What? Say it again. Yes. From what I see, 1 over x squared minus 4, which operation will I perform first when I replace x by 1? It's a square, right? It's still a multiplication, but it's a power, right? So that would be the first step. What will be the second step? Subtract 4. I get another number. And then what do I do finally? 1 by whatever I get. Excellent. So we basically decompose this function into 3 functions. We didn't even know. But we decompose it into 3 functions. Into x squared minus 4, into 1 over x. I only need 2. You don't have to come up with 3. So then give me the first function that you will say, oh, if you give me x equals 1, I will apply this function to it first. I'll get a number, and then apply the last function to create this.
X squared.
Right. I would consider x squared minus 4 as the first function, which is this. I get a number. Let's say I get whatever. Negative 3 in this case for 1. And then which function I apply to this number? There is no function as 1. You mean 1 over x. That's it. So now if you create this, let's say this one is g of x, and this one is h of x. I guarantee you that if you create h comp g of x, I guarantee you will get f of x. Because the inner function is x squared minus 4, and once you get a number, you apply 1 over x to it. Let's look at more examples and you'll understand.
Is that kind of like an inverse function?
No, not yet. The inverse function is a very good point. The inverse function deals with function composition. So for example, let's say you have in your pocket X dollars, and I'm giving you 5. Then you have x plus 5. But then 5 minutes later, I come back and I say, Bob, give me your 5 back. I'm creating the function composition. Addition of 5 and subtraction of 5. And that will give you just x. No change in your pocket. Because I gave you 5, and I use the inverse operation taking 5 back. If I give you 5, and I take 10 back, then there is a change of x that you have in your pocket. But if I'm giving you 5, and 5 minutes later I say, you know what, give it back to me, there is no change. Why? Addition by 5 and subtraction by 5 are inverse operations. Nothing happens to x. That's why we discussed the function composition, to lead to inverse functions. That's exactly it. Good, so let's look at another function decomposition. So see how this works. Let's say we have t of x, the square root of x squared plus 4. I would like you to find two functions, an inner and an outer, that create this function. So let's say I'm going to call them f comp g. Of course, g will be the inner, and f will be the outer. What do you think is the inner function? If I want to evaluate this function for x equals 5, what operation will I perform first? Which function will I apply first to 5? I can't. That must be the last one. Yeah, I have to perform this operation first. And when I'm done and I get a number, then I apply the square root to it.
No, so I'm saying you're going to square the input.
I can't square. This is not an equation. In an equation, when I solve an equation that is a radical equation, then I will square both sides. This is just a function, and I'm asked to decompose it into two functions. The inner function is x squared plus 4. The outer function is the square root of x. Let's try one more. Let's say p of x equals the absolute value of 2x minus 3. And we want f comp g. Everything is a function composition. Everything. Everything. So I want the inner, and I want the outer. What will you say? What will you consider the inner function that we have to use first? That's it. That's the inner function. This is what we have to determine first. If you ask me evaluate for 5, I will have to perform 2 times 5 minus 3 first. I have no choice. Once I get 10 minus 3, 7, then I apply the absolute value. We understand better function composition now? So now we do have to look at the inverse function. Bob is always ahead of us. I love it. Thank you, Bob. Okay, so I gave you a little silly example with f of x, x plus 5, and g of x, x minus 5. And now the question is, if we create the function composition, what do you think will happen? So let's say f comp g of x. What is the definition? F of?
X minus 5.
Right, but I have to write a g of x for everyone to see first. So this is f indeed of x minus 5. And now let's look at f. F says blah plus 5. But this is blah now.
What's the question?
I have to continue. What do I write? I have f to evaluate at x minus 5. F to evaluate at blah equals blah plus 5. Now this is my blah. I want it in here.
Is it x? Just x. Then 5.
But I still have to show it to everyone. You're right. You're perfectly correct.
X plus 5. I mean, x
x minus 5 and then
Plus 5.
plus 5. Indeed, these two go away and it's plain x. I have to check the other one. We have to determine the g comp f now, which by definition is g of f of x. Now I replace f of x by x plus 5. And let's look at g. G says whatever minus 5. But now this is my whatever. So how do I write this?
X plus 5.
Indeed. Yes. It turns out that both of them are exactly x. This happens only when f and g are inverses of each other. So we conclusion, f and g are inverses of each other. The notation for the inverse is this. It's not f raised to negative 1, and it's not 1 over f. The name is f inverse. We can also have g inverse, and so on and so forth. We're going to have t inverse. So now, we just looked at an example in which f comp g and g comp f both equaled x. This is what it's called, the property of inverse functions. Only when f comp g as well as g comp f, both ways, both directions if you want. In other words, I'm giving you $5 and I'm taking it back, or I'm taking $5 from you and I'm giving it back to you. It doesn't matter. If I add and then subtract, or I subtract and then I add the same quantity, nothing happens. So in both directions, f comp g and g comp f, if we get x, they are inverses of each other. This is the property of inverse functions. Any questions? Okay. Our next step is to look at, to try to find the inverse function, the inverse of a function, and also graph both functions, determining whether a graph has an inverse function. I have to explain that. Find the inverse of a one-to-one function in a minute. We'll talk about that. And then graphing an inverse function. Okay. When we discussed functions a long time ago, we looked at 3 sets of bubbles. We looked at this set, domain and range, of course. We looked at this set, domain and range, of course. And we looked at this set, any numbers you want here. So let's go back to the first bubble, first set of bubbles, domain and range, of course. Is this a function? This is a function. Question now. If I want to go backwards, from this point back to this one, from this point back to this one, and from this point back to this one, do I create a function or a relation? To each x only one y, to each x only one y, to each x only one y.
So it's still a function.
It's still a function. That's why this function is 1 to 1. Not only each x corresponds to only one y, but also each y corresponds back to only one x. So it's called 1 to 1. Only 1 to 1 functions have what? Only 1 to 1 functions have?
Inverse.
Indeed.
play hangman for a moment.
They only one-to-one functions have inverse sum functions. If a function is not one-to-one, it may have two inverse functions, or in other words, a relation. But we are not interested in those. So only if the function is one-to-one, meaning not only just only x approaches, each x approaches to one y, but each x corresponds to only one y, but also each y corresponds to only one x. That's a one-to-one function. That's why when I go backwards, I determine a function. What about this? What can you say about this one? It's not even a function. Excellent. What about this one? It's a function, but is it one-to-one? No. Function, but not one-to-one. Therefore, it does not have an inverse. This function is a function to each x only one y, but going backwards, I cannot create a function because to this x value, it will correspond to different y values. So this one is a function, but it's not one-to-one. Therefore, it does not have an inverse function. Okay. Now the next step is how to find the inverse function. Let's say f of x equals 2x minus 1. What type of function is it? Very good. It has a positive slope. Obviously, the graph will be like this. Do you think that this is one-to-one? Don't answer just yet. By the vertical line test, I know it's a function. By the horizontal line test, I will know whether it's one-to-one. For this y value, how many x values do we read? 1. For this y value, how many x values do we read? 1 for each, of course. So by the horizontal line test, not vertical, f of x equals 2x minus 1 is one-to-one. So with the vertical line test, we determine whether the graph is a function. With the horizontal line test, we determine if it's one-to-one. In other words, if it's going to have an inverse function. Okay, so let me give you 2 more examples, and then we'll find the inverse function of this. Since it's one-to-one, it will have an inverse. In a minute, we'll go back. So let me give you a few graphs. What about this? Is it one-to-one? What about this? Is it one-to-one? And what about this? If it is one-to-one. First one, is that one-to-one? No. By the horizontal line test, look how many different x values I get. It cannot be one-to-one. It's a function. By the vertical line test is a function, but not one-to-one. F, but not one-to-one. So it's a function, but not one-to-one. What about the quadratic function? Is it one-to-one? No. By the horizontal line test, it cannot be one-to-one. Not one-to-one. What about the x cubed? This is x cubed. We graphed it several times, so we have it on our list of transformations. Is x cubed one-to-one? Yes. By the horizontal line test, everywhere I cross the graph with the horizontal line, it will cross the graph in only one point. So this is one-to-one. Therefore, x cubed has f inverse. Okay, so coming back to so all these were by the horizontal line test. 2x minus 1. So here's what we need to do. Find f inverse for f of x 2x minus 1. Step number 1. Replace f of x with y. In other words, I'm saying replace this notation with y. And now I would like your permission. Would you allow me to do that? You can say no, we don't allow it because, or we do allow it because.
So what you do is perfectly allowable.
Exactly, because f of x and y are the same thing. They're the same, represent the same thing, two different notations, but they represent the same. Very good. Number 2. I want to interchange. Or swap x with y. Now, hold on. You have to say why. Show me why. Who allows you to do that? Here it is. This value is x for f, and this value is y for f. Agreed? But the inverse function will go backwards. It will have this as x and this as y. That's why I'm swapping x with y, because now this becomes x for f inverse. So when I do that, I get x equals 2y minus 1. In the next step, I'm interested in y, because y is now the new function. So in step 3, I have to solve for y. Can anyone tell us how to solve this equation for y? And divide by? Excellent. So x plus 1 divided by 2 is our y. And finally, number 4, we replace y with which notation? F inverse. Because now this new y is the notation f inverse of x is exactly what I'm looking for. So then f inverse of x equals x plus 1 over 2. I want to check. Here's what I claim. I claim that f of x, which was 2x minus 1, and f inverse, which is x plus 1 over 2, I claim that they are inverses of each other. And you say, I don't trust this, show me. And let's say I'm forced to show you. You tell me you don't trust it, and I have to show it to you. Okay. So what would I have to determine in order to show you that these are two inverses?
Switch x and y.
In other words, you're talking about the function composition. This is the only way we determine whether two functions are inverses of each other. So we have to find f comp f inverse, and then f inverse comp f. So this is f of f inverse. Again, you don't cross it out. I'm just making a point that this becomes x plus 1 over 2. So we have f of x plus 1 over 2. And now please tell me what to write. So f says 2, not times x, times what I plug in. So f says f of whatever is 2 times whatever minus 1. This is my whatever now. I can plug in x. So it's 2 multiplied by?
X plus 1 over 2.
Exactly, minus 1. I have to simplify first. I get x plus 1 minus 1, which turns out to be? That's it. So I show to you that indeed 2x minus 1 and x plus 1 over 2 are inverses of each other because I got x. What if I had gotten x squared or x over 3? Would you have considered these two inverses of each other? No, correct. Is it sufficient? No, it's not sufficient. I still have to show you F inverse comp F of x. What do you think that would be if this is x? If one direction is x, what do you think the other direction will be? Of course. But again, I have to show you step by step. Any questions?